Welcome to this very interesting piece of tool, which is my web app for students T distribution. And here we are today talking about some application part and some PDF part of students T distribution. So let us start. We in PDF definitely have a probability density function. So in this PDF, we take a particular value, T value, which is 0 by default in this case, and we try to find out the value of this particular phenomena T value at 0 in this case, which came out to be 0.3891. So which means there is a 38.91% chance of getting 0 value of T. But before we do that, before we get this number, we need to interpret and we need to understand this probability density function. So the function here it is, right? F for a particular value of T for given degrees of freedom. This is that function. And let us bifurcate this function. Let us divide this function, I should say, into certain parts and break down and understand it. First thing is the T value. Our T value represents observed statistic from our sample. Definitely we have a sample and we have a T value there. And this T value is inputted here and it is represented on x-axis, but this T statistics is computed like this. So this T statistics is definitely representing a ratio of deviation of sample mean from the population mean relative to the variability of sample data. What does it mean? We have a data and we have our sample, and x bar is that sample mean, and we have calculated it. We have a population mean, so we do the sample mean of our data minus the population mean, and then we divide it by what we call the variability of sample data. Here S is nothing else but sample's standard deviation, which measures the spread or variability of the sample data. N is of course the sample size, the number of observations in our sample, and T statistics is particularly useful when we have small sample size. So this is how we get the value of T statistics, right? This is T value. But we are calculating the probability, the T value at 0. And we see that on x-axis, there are negative values also. There is -5 here, there is -10 here. So the question arises, is it possible to have negative values of the sample mean? So the answer is yes, you can have the negative values. They just indicate that observed data is below what was expected. And in finance, this could occur, right? When an analyst believes that average return on portfolio should be a certain percentage. Maybe it should be I would say 5%. And then that person observes that our own stocks have a different percentage and our sample mean comes out to be only 3%. So then the variation would be -2%. So this would lead to negative T statistic. So this is what it means. So it is interesting that this function, this PDF function, we are observing the probability density at T value of 0 in this case, but in real life, this T value can be negative, and that is what the plot also shows, and for the reasons which I just mentioned. Second thing in the formula you see is given degrees of freedom. So degrees of freedom are linked to the sample size and the number of parameters we are estimating. So if in real life we are estimating, say, a 10 days worth of stock returns, then degrees of freedom would be 9, because the parameter that we are studying is 1 and that is mean. And third thing, this is interesting. This part that we see here in the numerator, this part. And this part is gamma function. It is evaluated as half of the degrees of freedom plus 1, and this normalizes the distribution, t distribution. So this is a normalizer function, the gamma function. And then there is one more in the denominator here, which is sort of very important to understand. And this represents this term, first part, normalizes the distribution by accounting for both degrees of freedom and pi. We see that here. Degrees of freedom and pi both are normalized here. And this second part is definitely again a gamma function which is evaluated at half of the degrees of freedom. So this second part here, starting from this gamma here, this selected one right now, highlighted in blue. And this next part here, which has an exponent also, this next part here, 1 plus t square divided by df, degrees of freedom, adjust the distribution based on t value and degrees of freedom. So t value is squared and it is divided by degrees of freedom. And this exponent part also represents something, and this is something which defines actually the distribution shape, this shape of distribution. So this is a very complex formula, but we tried to understand it by breaking down into these parts, and then we implement this formula in this app and through coding. And when we tried that, okay, at 0 the t value comes out to be 0.3891. The probability of 38.9% chance is there that our t value or the mean return of portfolio would be 0%. But this app is very interactive app. We can change the degrees of freedom here, maybe from 10 to 9, and here we can change the value maybe from 0 to 1, and then you see that accordingly that value has changed. It is now 0.2291. So this is very interesting app that helps us understand the t value of small sample sizes, and there are inputs which user can enter, degrees of freedom and specific t value, and then we get the t statistics, I should say, t value, and get the probability at that. So thanks for joining. In next learning we will talk about applications of t statistic and t distribution in quantitative and corporate finance, and I will see you soon here, and we will talk about these applications where you can use this t distribution. Thanks and see you soon.